Periodically over the last two chapters, we've been talking about quadratic equations and quadratic functions. To remind you what a quadratic function is, it is an equation in the form of y equals ax squared plus bx plus c, where a does not equal 0. Main thing to point out about quadratic equations is that there is an exponent of 2, and that's what makes a quadratic equation a quadratic equation. When you graph a quadratic equation, it is a parabola. That is the U-shaped graphs that we've talked about periodically as well. On a quadratic equation, the first term, the term ax squared, and there will be a number in the a position that is referred to as the quadratic term. The middle term, the one that just has an x to the first power with it, that is the linear term. And then c represents the constant term. Notice that there is no variable with the c value because that's what constant means. Variable means changing, but constant means it never changes. So the number in the c position is going to be the constant. We are going to spend a lot of time graphing. Every value a, b, and c does have a specific meaning. In a quadratic equation, the y-intercept is the c value. In linear equations, it's the b value, but in a quadratic equation, the y-intercept is the c value. The axis of symmetry. The axis of symmetry is the line about which the parabola is symmetric. So if I look over at this picture, the axis of symmetry is this line that runs right down through the middle of the parabola, that you can fold the parabola over to show that it is symmetric. The equation of that line uses the values of a and b to find it. Its equation is the x equals negative b over 2a. The axis of symmetry is where the vertex is. Remember, the vertex is the turning point of the graph. So right here, I'll circle that over the picture. That is the vertex. That is the turning point. The x-coordinate of the vertex is located at negative b over 2a, using that same formula that's used for the axis of symmetry. That's just the x value of the vertex, but to find the y value of the vertex, you would plug it back in to the original problem, which again is back up here, and that will give you the y value of the vertex. And then from that point, we could use the 1-3-5 rule that we've referred to in a previous lesson and to graph the parabola. Also applying what we've learned from previous lessons about maximum and minimum values is that the vertex of a quadratic function it will either be a maximum or a minimum. The graph of y equals ax squared plus bx plus c, where a does not equal 0, either opens up and has a minimum value when a is greater than 0, or it opens down and has a maximum value when a is less than 0. So let's look at these two pictures. The a value is very powerful when it comes to what the shape of the parabola is going to be. If the a value is positive, what that means is, if the a value is positive, that it increases on both the left and the right-hand sides. We refer to that as being an opening upward. So this opens up. Notice that the gap is opening on the upward side. So if it opens upward with an a value is positive, that means the vertex down here at the bottom indicates that it is a minimum. So a positive a value means the vertex is the low point, therefore that value is the minimum. If the a value is negative, that means that it is opening downward. So it is decreasing on the left and also decreasing on the right. So it's opening downward, so opens down. And what that means is the vertex is the high point, and if the vertex is a high point, then it is a maximum. So the first part of what we're going to do in a lot of is we are going to be graphing a quadratic equation. We are not going to use T-charts or tables of values to graph our quadratic equations. That will take an extremely long time, and there are shortcuts to doing so. We've talked about the shortcuts very briefly in a previous chapter, but we're going to talk about it a little bit more extensively in this chapter. So the first problem is we're going to graph f of x equals x squared plus 2x minus 3. State the domain and range. So the first thing we're going to do is we need to identify what the a value is, what the b value is, and what the c value is. So the a value is the number in front of the x squared. Remember, it's always in the form of ax squared plus bx plus c. This is the form for a quadratic equation. So the a value is the number in the a position, and the number in the a position is the number in front of x squared, and since I don't see a number in front of the x squared, that means the a value must be 1. The number in the b position is the number in front of the x to the first power, and that number is a positive 2, so the b value is 2. And the c value is the number at the end that does not have a variable with it, and that c value is going to be negative 3. So identify the a, b, and c first, because remember, a, b, and c all have specific meanings in terms of graphing the quadratic equation. All right, so it's an easy 3-step process. Step number 1 is to find the vertex, and we find the vertex using the vertex formula. The vertex formula is the x value of the vertex equals negative b over 2a. Become very familiar with that. You're going to use that a lot. That is negative b over 2a. So in this particular case, we're going to have negative 2, because the b value is 2, over 2 times 1, because the a value is 1. And that would be negative 2 over 2 times 1 is positive 2, and that equals negative 1. That is the x value of the vertex. But we have to find a y value to graph that point. So to find the y value, we're going to go back to the original function, which is y equals x squared plus 2x plus minus 3. We're going to replace what we found for x, this negative 1. We're going to replace that in for x in the original function, and we're going to solve for y. So that's going to be negative 1 squared plus 2 times negative 1 minus 3, and this will be what y equals, the y value of the vertex. Follow your order of operations. First off, negative 1 squared is how much? If you take negative 1 and square it, you get positive 1. Don't trust your calculator on this, because you are probably going to type it in incorrectly, and your calculator may tell you it's positive 1 or negative 1. Negative 1 squared is positive 1. Then we do our multiplication. We have 2 times negative 1, which is negative 2, minus 3. And when you take 1 minus 2 minus 3, that is going to give you negative 4. So our y value of vertex is negative 4. So that means that our vertex is going to be located at negative 1, negative 4. This is by far the longest step of the process, is to find the vertex. But it is our starting point, and it is the most important point. So I'm going to place a point at negative 1, negative 4, which is right there, as you can see on the graph. That is step 1. Step 2. Step 2, the c value is the y-intercept. So we look back into the original problem. The original problem has a c value of negative 3. We identified it over here. I just highlighted it. A c value of negative 3. So I will place a point on the y-axis at negative 3. So that is right next to the vertex in this particular case. And that's step 2. I guess I didn't write a step 2 there, but it is step 2. Step 3, apply the 1-3-5 rule. Now the 1-3-5 rule is now going to be modified a little bit this chapter because in previous chapters we didn't have any stretches or compressions. The graphs always were the same width and the same height. But in this case, we're going to start seeing some tall skinny graphs, which are stretches, or short little fat graphs, which are compressions. So to modify the 1-3-5 rule, you're going to take 1-3-5 rule and take it times the A value. So the 1-3-5 rule will take times the A value, which is +1. So when you take 1-3-5 times +1, again, that's the A value, you still get 1-3-5. So that means we will start at the vertex. Start at the vertex. We will go out 1 both directions and up 1 and place a set of points there. Notice that when I do that, I hit the y-intercept. That is a very good indication that we are likely correct. From those points, we will go out 1 both directions, but now we're going to go up 3. So you can see I'm counting up 3. Place a point there and there. And then from those points, we will go out 1 again, but this time we're going up 5. Place points there and there. And then we draw our best U-shaped graph that we can. It is rounded at the bottom. It is not perfectly flat. It is not pointy. And notice that the sides of the parabola do not go straight up and down either. So that is my best U-shaped parabola, and that is the graph of that function. It also asks us to state domain and range. So unless there is some real-world limitation, the domain is going to always be all real numbers. The range is always going to be based upon the vertex. The vertex is either the highest point or the lowest point. So remember, the y value of the vertex was back up here, was y equals -4. So the range is going to be, in this case, y is greater than or equal to -4, because -4 on the vertex was the lowest point, which means the rest of the graph is above it. So the range has to be larger than -4, hence that's why I have y is greater than or equal to -4. So that is the full way to graph it in 3 easy steps.